have finished learning the terminology about the circles. Now we get to the theorems of the circles, right? So let's get started. The theorem number 1 says equal chords subtend equal angles at the center of the circle. So let's draw a circle first. This is the circle that we have drawn, right? Now it's given there are two chords of a circle which are equal. So chord is what? Chord is a segment joining any 2 points. So that's what we are doing here. We are taking two chords, right? Right, we are taking two chords, right? We have taken two chords. Now we have to prove that these two chords subtend equal angles at the center. So let's see first what's given. What's given? Let's look at that first. So given is this. Given is BC chord equal to DE chord, right? I should rename the center of the circle. Should rename it to O, right? It's better that you name the center of the circle as O, right? So what it is given, two chords are equal, and also a circle C, a circle which has a center O and radius R, right? So what we have to prove? We have to prove that the two chords subtend equal angles at the center, right? So firstly, for that we need to construct, right? So let's join B to O, and then O to C, and again O to D and O to E. To remind you, OC and OD is not a straight line, as it is clearly visible also, and it is not actually a straight line. So don't ever think that these two angles will be equal as they are vertically opposite. This is not, BE is not a straight line, neither is CD, right? CO is a different line, OD is a different line, right? So what we have to prove? We have to prove that angle BOC is equal to angle DOE. That is what we have to prove. Now what's the proof? So in the proof, we will follow very simple step. We will follow the congruency rule of the two triangles. Now we can see two triangles here. So in triangle BOC and triangle DOE, right? So by the definition of radius, we know that the line segment joining the center of the circle to any point on the circle is called the radius. Hence BO is the radius of the circle and CO is also the radius of the circle, right? This is also the radius of the circle, this is also radius of the circle, because they all fulfill the criteria in which these are the segments which are joining the center to the points on the circle, right? That's what we did. So firstly, this is equal to this is equal to this, right? This side. So in this triangle, and this side is equal to this side, it is given to us in the question that the two chords are equal. So that's what we will do. We will do OB is equal to OD, also CO is equal to EO, right? Why? These are the radii of the circle. This is also, these are also radii, right? Also the third, BC is equal to DE. This is given to us already. So obviously the two triangles, triangle BOC is congruent to triangle BO. BO was equal to OD. So obviously DOE, right? By SSS congruency. right? So by SSS congruency I have fulfilled that. So angle BOC is equal to angle DOE, and this is by CPCT, corresponding parts of two congruent triangles, right? So thus this angle is equal to this angle. This is what we had to prove. So what does it tell you? Okay, if two chords are equal, right, then they will subtend equal angles at the center of the circle. That's what we have to prove, and we had proved that, right? So the most important thing that was used here was congruency. We used to know earlier only, but this is the thing. Concept of the radius has been used to make the two triangles congruent. That's what we'll be using add, right? So let's move forward. Let's erase it first. Okay, now let's move forward. Next theorem. Theorem 2 says if two chords subtend equal angles at the center of the circle, then the chords will be equal, right? Let's draw the diagram. Yes, it is given two circles subtend equal angles at the center. Okay, two chords. Now in this is a converse case of the previous theorem. It's not given the two chords are equal, but we have to prove that the two chords are equal, but it's given that they both chords subtend equal angles at the center. So let's draw the chord first. We have drawn the two chords. Now let's write the given first. So given circle which has a center O and radius R, right? Also it is given that the two chords subtend equal angles at the center. That's what we have drawn, and it is given in the question that this angle and this angle are equal. These are equal. It is given. So angle GOH is equal to angle JOI, right? So what we have to prove? We have to prove that GH is equal to IJ. GH is equal to IJ. What is the proof? What is the proof? Let's prove it. Again, we'll follow the congruency of the two triangles. You can clearly see there are two triangles. So we will consider those two triangles. In triangle GOH and triangle JOI. In triangle GOH and JOI, what do we observe? Firstly, OH is what? It is a radius. OG is what? It is a radius. OJ is what? It is a radius. And OI is what? It is also a radius. Because it fulfills the definition of radius. To remind you again, point line segment joining the center of the circle to a point on the circle is the radius, right? So I, J, H and G were the points on the circle, and that's why if we join them to the point O, they become radii. Okay, that's what. So again, this is equal to this is equal to this side, and one angle is equal. So OG is equal to OJ, OH is equal to OI, and angle GOH is equal to angle IOJ. This is due to the radius or the radii, you can say the plural radius. This is also radii of the same circle, obviously, and this is given to us. Because it is given to us, what congruency can we see here? We write GOH, right, angle O is equal to angle O, so angle O should come in between, and OG is equal to OJ, so the triangle should be JOI, right? JOI. By what criteria? By SAS criteria. Side angle side. The angle is included between the two sides. That's why the side angle side criteria. And thus we get GH is equal to JI. GH is equal to JI. What is the reason? The reason being, if two triangles are congruent, then the corresponding parts of the two congruent triangles are also congruent, and the two line segments can be congruent only if they are equal in length, and thus these two are equal, and these two, to remind you, these are the chords GH and IJ, and they are equal. Thus we have proved what we had to, right? So we are done with the second theorem also. Aren't these theorems easy? Except for the congruency and one radius concept. Hardly any concept is used here, right? So but we have to remember these theorems to be used in the further proving of theorems also, or the questions, right? So let's get back to the third theorem, right? The third theorem, it says what? It says perpendicular drawn from the center to the chord bisects the chord. Now it says that if we draw a perpendicular to the chord from the center, so let's take a chord first. This is a chord, right? Now let's draw a perpendicular. Let's draw a perpendicular, and we have drawn a perpendicular. If we have drawn, so the angle, let's measure the angle. The angle is 90 degree, right? So we have drawn a perpendicular from the center to the chord. Now this has to bisect the chord, right? So firstly, let's draw a construction, right? Construction will be line segment from this point to this point, and then this point to this point. This is the center, O is the center, right? So let's add the given. What's given to us? Given is a circle C, center O and R, right? In which we should name this point, right? We should name this point as something. This point as M, right? So in which OM is perpendicular to KL, right? KL is a chord of the circle, right? Or we can write that angle OML equal to 90 degree. And if OML is 90 degree, also OMK is 90 degree, because KL is a straight line, right? So now what we have to prove? We have to prove that Km equal to ML. I have to prove this. Now what is the proof? As you can see in the construction, we have already joined the point K of the chord or on the circle to the center O, right? That's what we are doing. So we'll take, again we can see two triangles. In triangle KOM and triangle LOM, what we can see, this is 90, so this angle is also 90 degree. Both angles are 90 degree. And can you see KO is the radius and OL also the radius, so these two will be equal. And can you see this is the common, right? So OM equal to OM. Why? It is the common side in both the triangles. It is the common side. Again, OL is equal to OK. Why? Because these both are the line segments which are the radii of the same circle. Also, angle OMK equal to angle OML equal to 90 degree. It is given to us, right? It is given. So what we get to know that triangle KOM is congruent. Now how it is congruent? 90 degree, right angle, the side opposite to the right angle is the hypotenuse, and OM is any side. So by RH congruency we have found that these two are equal. Now see KOM, if we write the name as KOM, M point is at last, so obviously the M will be at last, right? Now KO is equal to OL, right? KO is equal to OL. The name will be O will be here, right? And LOM will be the name, right? Why? Because KO was equal to LO or OL, but OM was equal to OM common. So M was at last, so O had to come in the second. So this is the thing, and that's proved by RHS. Now what we can see, if two triangles are congruent, the corresponding parts are also equal. So obviously KM equal to LM, KM is equal to LM. Why? Because of CP CT, right? KM equal to LM, and thus we have proved that this is equal to this length. We can see also, if we measure the length of KM, we find 2.42, right? And LM is also 2.42. That's what we wanted to prove, right? You can see KM is 2.42, LM is also 2.42, right? So this is being proved by the calculation also, the actual calculation that we took for the chord. So this proves it. Is it clear? That's what. So let's move on to the next theorem. The next theorem says that the line drawn from the center of the circle to bisect the chord is also perpendicular to the chord. It is just the converse of the previous case, right? It is the converse of the previous case. We will see it. Also, let's rename the center first. Okay, now first a chord, right? The line drawn from the center of the circle to bisect the chord. Now we have to draw a line as if it is the bisector. So let's draw a line segment, this point to this point. It is a bisector. It is given that this is a bisector. So let's write what's given to us. Given thing is a circle C with center O and R, right? So center is C, center is O, and the radius is R. Also it is given Mn is a chord of a circle. Mn is a chord of the circle, right? Mn is a chord, and also it is given MP is equal to PN. MP is equal to PN. It is given in the question. The line that we have drawn OP, it bisects the chord, so it is given, right? So take a different color. Okay, now what we have to prove? To prove that angle OPN or angle OPM is equal to 90 degree. You have to prove this. Let's draw the construction. Construction will be join OM and join ON. O to M and O to N, right? We'll join them. So let's join it. Let's take a segment O to M and then O to N. We have joined, right? So we get back to proving. So proof. What's the proof? The proof says again in triangle OPM and triangle OPN. In triangle OPM and triangle OPN, we have been given that PM is equal to PN. It is already given in the condition, in the question rather. PM equal to PN. Also you can see that OM is the radius, this is also the radius, right? OM equal to ON. What it is? It is the radius. Also we see that OP is equal to OP, and it is common side in both the triangles, so this will be common, right? So triangle OPM will be congruent to triangle OP equal to OP and PM equal to PN, so the name will be OPN, right? And by obviously the three sides are equal, so corresponding the congruency will be SSS, side congruency. And now because of CPCT, what we find, angle P and angle P are equal, so angle OPM is equal to angle OPN. Let both of them be equal and let them be X. So this angle is X and this angle is also X. Both the angles are X. MN is a straight line, so X plus X equal to what? Is equal to 180 degree. This means 2x is equal to 180 degree. And this further means that x is equal to 90 degree. X equal to 90 means this is equal to 90 and this is also equal to 90. Hence we have proved what we had to prove, x equal to 90. So angle OPM equal to 90 degree and angle OPN equal to 90 degree. That's what we have to prove, and we have proved that, hence proved, right? So if you draw any line from the center to any chord, and the condition is that the line drawn to the chord should bisect the chord, then that will be perpendicular. Any line drawn will not be perpendicular. Only those lines which bisect the chord will be perpendicular, right? I hope it is clear. So let's move to the next theorem. Theorem 5 says equal chords of a circle are equidistant from center of the circle. It means that if there are two chords which are equal, then the distances of those chords from the center will also be equal. Let's see. So firstly, let me draw a chord, rather two chords, because these are, and it is given in the question that they are equidistant in length, right? So let's take a new color. Okay, given, what's given? Given the two chords are equal. First is a circle which has a center O and radius R, right? Circle has a center O and radius R, and two chords which Tu is equal to Rs. These are the two chords that we are given, in which Tu is equal to Rs, right? What we have to prove? What you have to prove? You have to prove that the distance of the chords from the center are equal, right? So let's draw the construction first. So this distance, this is not any kind of distance. This is the perpendicular distance. We are talking only about the perpendicular distance, right? Again, these are the perpendicular distance that we are talking about. So let's write what we have to prove. OV equal to OW, right? And OV and OW are perpendicular distances of the chords from the center, of the chords from the center of the circle, right? So let's prove it. Before that, let's do some construction work. What construction do we require? Construction that we require is that we have been doing all throughout during the proving of theorems, is to join this point to this point, this point to this point. That is, we need to join O to U and O to S, right? We have joined these. Now firstly, to remind, this is 90 degree, also this angle is 90 degree. This is the radius, this is the radius. This is 90, and let's see what we can do. So proof. Firstly, is it given that the two chords are equal, that is Tu equal to Rs? Yes, it is given. It is given. Do we know from our previous theorem, if a perpendicular is drawn from the center to the chord, it bisects the chord? So Tu by 2 equal to Rs by 2, dividing both sides by 2, right? If we divide both sides by 2, we get this by 2, both sides is also equal. So is Tu by 2 equal to UV? Yes. And is Rs by 2 equal to SW? Yes, right? That's what we got. We got that this length is equal to this length, right? Now again we'll do the congruency. So in triangle OUV and triangle OWS, what we observe? We observe that OU is equal to OS is equal to radii of the same circle, and thus they will be equal. right, radii. Also we have just proved that uv equal to sw, proved above. We have proved above, and we have actually used one of the theorems that we have proved previously, right? Perpendicular drawn from the center to the chord bisects the chord. That's why the only perpendicular distances we are considering, right? Also, angle OVU equal to angle OWS is equal to 90 degree. 90 degree. So again, right angle, hypotenuse and one side. So the congruency that is followed is RHS. Again, writing the name of the triangle, OUV is congruent to angle V is at 90 degree and the W is 90 degree, so W will be last. OU equal to OS, so this will be the name OSW, and the congruency will be by RHS. Thus we see the corresponding parts are equal. OS equal to OW, OS is equal to OW, right? OS equal to OW by CP/CT. I said OS, okay, sorry, it's OV equal to OW. I said OS, it was by mistake. OV equal to OW, right? OV equal to OW, right? This is V. You can see corresponding part OV equal to OW. OV equal to OW by corresponding parts of congruent triangles. Thus we have proved if two chords are equal, then the perpendicular distances of these two chords from the center are also equal. That's what we wanted to prove, right? So let's move forward, right? Next theorem. If two chords are equidistant from the center of the circle, they are equal in length. Now it is just the converse of the previous theorem. If the two chords are equidistant from the center, right, then the chords of the circle will be equal in length. So let's draw a circle first. Draw a circle, right? Let's move this circle a bit. Okay, so now let's draw two chords on the circle. This is one chord, this is the another chord. What it is telling us, if the chords are equidistant from the center, so this will be the perpendicular distance of this chord and this will be the perpendicular distance of this chord, right? The angle will be 90 degree and here also the angle will be 90 degree. It is also given that the two chords are equidistant, means OW equal to OV, right? OW is equal to OV. So let's write given. What's given to us? Thing that is given to us is a circle C, center O and radius R, right? Circle with center O and radius R, and in this circle what we are given more, it has two chords TU and RS are chords of the circle, such that the distance OV is equal to distance OW, right? This is given, where OV and OW are perpendicular distances of the chords, from center, from O, right? What you have to prove? So to prove, we have to prove that the two chords, that is Tu is equal to Rs. We have to prove this. What will be the construction? Construction: join O to U and O to S. Join this. So we'll prove it, right? Let's do the construction first. O to V will join, and then O to S. Join these 2 points. So if we join it, we observe that OU is the radius, OS is also the radius of the circle, right? So again, in triangle OUV and triangle OWS, right? What it is given? It is given that OV is equal to OW. This is given to us. Given that OV equal to OW, right? Also you can see that OU is equal to OS. Why? Radii. This is given, and this is equal to radii. Also, what is given? Angle OVU equal to angle OWS is equal to what? 90 degree. This is also given because it is a perpendicular distance, right? So again, triangle OUV congruent to V is 90 degree, W is 90 degree, so W will be at last. OU equal to OV equal to OW, so O will be at first and S will be here, and the congruency will be called as RHS. Now because of this RHS congruency of the two triangles, can we find something over here? Corresponding sides OUV equal to SW, UV equal to SW. This we have found out. So since UV equal to SW, why? The reason being CP CT. Now if UV equal to SW, so 2 into UV will also be equal to 2 into SW, multiplying to both sides. We know that perpendicular drawn from the center to the chord bisects the chord. So 2 times UV will be equal to TU, and 2 times SW will be equal to RS. Why? Because of the reason perpendicular from center to the chord bisects the chord, right? Bisects the chord. So it's given key, we have proved it, TU equal to RS, that the two chords are equal in length, and if the distances of the two chords, perpendicular distances to be precise, are equal, then the two chords will be also equal, right? So these 6 theorems, these have much importance in your circle chapter. Will be coming in the next lesson with some more proofs. Till then, bye bye. Thank you.